In this exercise, we're going beyond linear functions at this point to nonlinear functions. In this case, we're asked to graph f of x equals x squared, which is a quadratic. That simply means that x is being taken to the second power. The variable, the independent variable, is being taken to the power of 2. So I've made this little chart here, x f of x and x f of x. This should look really similar because, once again, essentially all we're doing is the difference between this and what we've done in the past is that before we had y equals x squared. Well, now we have f of x equals x squared. So technically on this graph I should be writing, instead of y, f of x. But again, the process is still the same, and you'll often see y still being the vertical axis, and in fact I think most of the examples you've seen to this point, if not all of them, use y instead of f of x on the actual graph. So what does this little chart mean? It's the same process as before. We replace a number for x, we simplify, we get what f of x, the value of f of x is, and then that gives us our x f of x coordinates to plot the point. So let's start with, let's say x equals -3. So at x equals -3, we have f of -3 equals -3 squared, which equals 9. So x is -3, f of x is 9, so our point is -3, 9. Let's go with x equals -2. I'm not going to write out x equals again because we know what we're doing as far as we're substituting in -2 for x. So f of -2 equals -2 squared, which equals 4. So we'd have -2, 4, and our point would be -2, 4. And then we will repeat this process. F of -1 equals -1 squared, which equals 1. 0, f of 0 equals 0 squared, which equals 0. And then you'll notice a pattern here. I'll go ahead and write out our x values. 1, 2, 3, and last but not least 4. So f of 1 equals 1 squared, which equals 1. F of 2 equals 2 squared, which equals 4. F of 3 equals 3 squared, which equals 9. And f of 4 is actually going to be off our graph because that equals 4 squared, which equals 16. So our corresponding points would be 1, 1 from f of 1, 2, 4 from f of 2, 3, 9 from f of 3, and then 4, 16 from f of 4. So let's plot our points. We start off with -3, 9. Let's make every other mark. Actually, we'll just keep the scale the same. Let's make this one and this one. So we start off with -3, 9. So -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. -2, we're at 4. -2, 4. -1, we're at 1. 0, we're at 0. And then it's in the same spots on the other side. 2, 4, 3, 9. And what we have with pretty much any quadratic is a parabola. It looks like kind of like an upside down U or V. So this would be the graph of f of x equals x squared.